Welcome to Module 2, Lesson 3, Linear Relationship Word Problems. Let's start with our Level 1 beginner level problem. Ben, Cam, and Justin are lumberjacks. The number of trees they chop down is given by B plus 2C plus 3J, where B is the number of hours Ben spends shopping, C is the number of hours Cam spends shopping, and J is the number of hours Justin spends shopping. How many trees do they chop down after Ben spends 8 hours shopping, Cam spends 3 hours shopping, and Justin spends 4 hours chopping? So we have our expression here, B plus 2C plus 3J. In a question like this, all we have to do is substitute our values for our variable. So we know B stands for the number of hours Ben spends shopping. The question tells us he spends 8 hours shopping, so we're going to substitute 8 for B. We're going to substitute 3 for C because the question tells us Cam spends 3 hours shopping. And then we'll substitute 4 for J because the question tells us that Justin spends 4 hours shopping. So we have 8 plus 2 times 3 plus 3 times 4. If you're using a graphing calculator, you can just enter this expression in exactly like this. But feel free to solve algebraically and simplify. So we get 8 plus 6 plus 12, which gives us 26. So our answer is 26 trees. Please make sure when working with word problems, you always include your unit. Don't just answer the question as 26. Make sure you specify that it's 26 trees. Let's take a look at another one. Mara is M years old and her younger brother Kyle is K years old. If Mara is 3 years older than Kyle, which of the following correctly expresses K in terms of M? So let's see, what's the important information here? Mara is 3 years older. Anytime I hear a phrase like that, I know that we're going to have to add 3, right? So Mara is 3 years older than Kyle, so we can create an equation for Mara, right? Mara is M. She's going to be K plus 3, right? 3 years older than Kyle. So we have an equation for Mara's age. But take a look at your multiple choices. They're all set equal to K, and our equation is set equal to M. So we'll need to use inverse operations and just rearrange this equation to solve it for K. So let's take this plus 3 and minus 3 on both sides. The 3's cancel out. Now M minus 3. We cannot subtract 3 from M because they're not like terms. M is a variable. -3 is a constant. So M minus 3 is simply just M minus 3, which is equal to K. And that is choice B. Please pause this video and work on the Lesson 3 Level 1 problems in the workbook. Moving on to Level 2, our intermediate level. Each day, Stephanie records the height of a plant for her science lab. The function h of x equals 1.5x plus 3 represents the height of the plant in centimeters on the x day. Interpret what 3 in the equation represents in this scenario. Interpret what 1.5 in the equation represents in the scenario. So a lot of these word problems require you to interpret either what the solution means or what parts of the equation stand for. So in this case, we have a linear equation, and they want us to interpret what each piece of the equation represents in context of the problem. So let's recall our slope-intercept form y equals mx plus b. When we deal with word problems, m is our slope, and in word problems, it represents the rate of change of something. The rate of change that something is growing, the rate of change that something is moving. Our slope will represent our rate of change. Our y-intercept will always represent the initial value, the starting value. The y-intercept, or the starting value in a problem, will always be the y-intercept on a graph. So let's take a look at the equation we have here for our function h of x. Our slope is 1.5, right? Because that's the m value. And we have 3, which is our y-intercept. So 3 is the y-intercept. It represents the initial value in a word problem. So in this case, it represents the initial height of the plant. 1.5 is our slope. It represents the rate of change at which the plant is growing each day. So if you wanted to use a complete sentence to answer this problem, you would say, a Stephanie's plant is 3 centimeters tall initially and grows at a rate of 1.5 centimeters a day. Let's take a look at another one. We're going to engage in 3 reads for this problem because it requires a little more critical thinking. Priya is traveling by train for her job. The equation x equals 78 times the difference of 7.7 and t gives her the distance from her destination, x, after t hours. How long will it take Priya to reach her destination? What is the story about? Please take a minute and fill out this section of the 3 reads template. Moving on to our second read. Priya is traveling by train for her job. The equation x equals 78 times the difference of 7.7 and t gives her the distance from her destination, x, after t hours. How long will it take for Priya to reach her destination? So let's take a look at our quantities and relationships. We have x, which represents the distance from her destination. We have t, which represents the number of hours. And we have 0. Now, why would I choose 0 for one of our quantities? I don't see 0 in the problem, right? What could 0 represent? Well, the question is asking, how long will it take Priya to reach her destination? If x is the distance from her destination, right? She reaches her destination when her distance from the destination is 0, right? 0 is the distance when she reaches her destination, right? It's the value of x that we're going to use to solve for t, right? When the distance from her destination is 0, it means she's reached her destination. She's gotten there, right? So that's why we're going to have to set this equation equal to 0. So let's take our quantities and relationships and solve the problem. Here's our equation, right? And again, we want to solve for t because the question is asking how long it will take for her to reach her destination. So we need to know the number of hours, right? We're going to substitute 0 for x because we know when her distance from her destination is 0, then she's reached it. Okay, so let's solve for t. We're using inverse operations, right? So we'll divide both sides by 78. 0 divided by 78 is 0. And we're left with 0 equals 7.7 minus t. Let's use inverse operations and subtract 7.7 on both sides. We get negative 7.7 equals a negative t. Now notice how some people think that we've found our solution at this point, but we have negative t, not positive t. So this negative sign basically means that our coefficient is negative 1. So we'll divide both sides by -1 and get positive 7.7 hours equals T. Once again, please, please, please make sure that you don't just answer this as 7.7. You answer it as 7.7 hours. Please always include your unit. Moving on to the third read. Priya is traveling by train for her job. The equation x equals 78 times the difference of 7.7 and t gives her distance from her destination x after t hours. How long will it take for Priya to reach her destination? Please pause this video and take a few minutes to think of any mathematical questions that you could ask. Please pause this video and work on the Lesson 3, Level 2 problems in the workbook. Moving on to Level 3, the expert level. We'll definitely be using 3 reads for this question, as it is a question that involves way more critical thinking than the ones that we looked at in Level 1 and Level 2. So first read. A charging station can only charge cell phones and laptops. Cell phones use approximately 3 joules per second when charging, and laptops use approximately 40 joules per second when charging. Which of the following equations represents the relationship between the number of cell phones C and the number of laptops L that could be charging when the station's output is exactly 160 joules per second? What is the story about? Moving on to the second read. A charging station can only charge cell phones and laptops. Cell phones use approximately 3 joules per second when charging, and laptops use approximately 40 joules per second when charging. Which of the following equations represents the relationship between the number of cell phones C and the number of laptops L that could be charging when the station's output is exactly 160 joules per second? Let's take a look at our quantities and relationships here. Again, this is the most important read. So we have 3. This represents the joules per second when charging cell phones. Then we have 40, which represents the joules per second when charging laptops. We have 160, which is the charging station's exact output. We have our variable C, which is the number of cell phones, and our variable L, which is the number of laptops. So let's take this information that we've organized in the second read here and use it to solve our problem. So we can write an equation with the information that we have, right? We could start with 3C plus 40L equals 160, right? 3 joules per second per cell phone plus 40 joules per second per laptop equals 160 joules per second. Now, this equation is great, but if you take a look at your multiple choices, all of the equations are expressed in terms of C, right? They're all solved for C. So in order to find which answer is correct, we need to use inverse operations and solve for C. So we'll subtract 40L on both sides. Plus 40L and minus 40L cancel out. We get 3C equals 160 minus 40L. Now we'll divide both sides by 3. The 3's cancel out. And we get C equals 160 over 3 minus 40 over 3L. If you look at our choices, we don't have one that matches our answer exactly, right? But if you take a look at choice B is exactly the same as our answer, the answer that we got. They just switched the terms. they switched 160 over 3 and negative 40 over 3L, right? They're the same thing because addition is commutative, meaning that the order of the addends do not matter, right? They mean the same thing. So our answer is choice B. Moving on to our third read. A charging station can only charge cell phones and laptops. Cell phones use approximately 3 joules per second when charging, and laptops use approximately 40 joules per second when charging. Which of the following equations represents the relationship between the number of cell phones C and the number of laptops L that could be charging when the station's output is exactly 160 joules per second? What mathematical questions you could ask? Something I might ask my students is, how could you express the equation in terms of L rather than C, right? How could you solve the equation for L? So take a moment, pause this video, and think about what mathematical questions you could ask. Please pause this video and work on the Lesson 3 Level 3 problems in the workbook. Once you're finished with the problems in the workbook, please stop this video and move on to the next video, which is Lesson 4.